Hello, everyone. I hope there are more people will join, but thank you for those that have joined already for joining this session. So this is a continuation of what we've been doing since morning. As you know, today's summit has explored different components of the cooling ecosystem, from feasibility assessment and designing code rooms to financing. So the idea is later during the day, we will delve deep into data and digitalization, market access, community ownership, and so on and so forth, right? But here's the exciting part. All this work that we've done raises an important question, which is how do we know if cold rooms are actually delivering climate benefits, right? Are we making a real impact, or uh, if so, how can we measure this impact? While this is not really a straightforward question, in your virtual coaching assistant project, we developed a methodology to capture greenhouse gas reduction, whereby a company registered on the Cultivate app can track their greenhouse gas emission reduction directly, right? Uh, just to also highlight that most of the data we use for this calculation were from baseline weekly survey from farmers. So maybe we could probably just present a little bit of the farmer's dashboard just to give you an insight as to what the interface looks like, then before we delve deep into today's presentation. Jackie, do you want to present the? Yeah. So this is how the farmer's dashboard looks like. And later in my presentation, I will highlight some of the interface just for you to see. Thank you, Jackie. Yeah, thank you so much, Jackie. So just for more information on the Cultivate app itself, please do well to join the session 10, which will be at 3:45 Central European Time. Okay, great. So maybe before I delve already into today's presentation, let me just give a quick introduction about myself. So I am Daniel Onwude. I have a background in agricultural engineering. I've worked in your virtual coaching assistant project for the past 4 or 5 years, where we piloted the solution in Nigeria, India, and the Philippines. I was the main person that developed this approach, which is the life cycle assessment approach, which is now integrated into the Cultivate app, right? Great. So please, I just want to mention that if you have any question, you could ask at the end of this presentation, but I also like my sessions to always be very interactive. So please feel free to indicate if if you want to ask a question directly. Okay. Great. So for me, the first question I always ask myself when we talk about cooling is that, okay, yes, cooling preserves food, but at what cost, right? So that's the central trade-off that we're going to explore today. Is the energy used for cooling justified by the environmental benefits of reducing food loss, right? So if you look at your screen, we have basically two scenarios. So let's say The first scenario is a farmer without cooling, and then we have another scenario, a farmer with cooling. Now, what does this mean? So a farmer with cooling would have, a lot of benefits, right? So he or she could extend shelf life and reduce spoilage, right? But the question is then, at what cost? So for me, the trade-off is clear: fewer emissions from wasted food versus new emissions from powering cold rooms. Because as I said earlier, cold storage has a huge potential. It can extend shelf life, reduce food loss, and then in turn improves food security and then farmers' income. But these benefits always come at an energy cost. So the key question here is, do the benefit outweigh the environmental cost? So this is the question that we try to answer with this approach, right? So we decided to deploy a systematic way that can then compare the emissions avoided by reducing food loss with the emissions created by running a cold room. So, and this approach, we use the life cycle assessment method, or what is often called LCA. So, with this method, we compare two scenarios: one where produce is cooled using decentralized cold rooms, and one where no cooling is applied and losses are higher. So, to make this assessment meaningful, we also need detailed operation data, right? So, things like energy source, environment consumption levels, insulation quality, storage volume, and even target room temperature, right? So that is why we've integrated, or we've used the Cultivate app now to able to collect some of this reliable data that feeds directly into the real-time environmental impact assessment. And the idea is then to ensure that our model also reflects the actual condition in the field. Okay, so now I'm going to delve a bit deep into the three, I would say the three different components that makes up, this approach. So I have, the first part would then be on the LC methodology itself, and then how we collected data using the Cultivate app, and then how this is being interpreted into actual metrics that the cooling service providers, the farmers, could then take action with, right? So now let's look at the LCA, what LCA is about. So, as I said earlier, it's often called life cycle assessment, or LCA. So there are two parts to this. We have the life cycle perspective, and then we have the quantification of relevant environmental impact, right? So just to give a short introduction, the LCA is a method that is often used to evaluate the environmental impact of a product, process, or system throughout its life cycle. So that means from material extraction or production to disposal. Okay, and then the life cycle perspective basically considers all stages of product or process or system production processes, which include, as I said earlier, resource extraction, manufacturing, transportation, use, and disposal. Right, we're going to see more about these in the subsequent slide. And then when you talk about quantification of relevant environmental impact, then we focus more on the impacts such as the energy consumption, the greenhouse gas emission, the water usage, and even pollution. Okay. Now let's maybe have put a picture as to what this idea is. So to make this more concrete, let's take an example of a fruit that is being produced. So it starts from the farm, it goes through different processes. So this is just a typical short supply chain, local supply chain. So it goes through storage and then processing and even ripening before the end of life. And in each of these phases, we have different things that takes place. Like during the farm production, we have the feed operation that involves diesel, fertilizer, manure. We have the inputs uh, are used, such as the seeds, the pesticides, the water. We have the energy used, like irrigation, and also the machines that is used for farming. And then we go to storage. We also have resource use like water and electricity. And then in some cases, the stakeholders also use preservative, during storage. And then we have the packaging aspect, right? Then this also involve materials, energy that is used to produce these materials. And then we have ripening process, which also consume a lot of electricity. And then we have ethylene also production, which also affects or which has an impact to the environment. We have cleaning. Most times, cleaning is not using water. In some cases, detergents, and all these contribute to environmental impacts, right? And then the product could be processed as fresh produce, frozen, dried, and even canned fruit, right? And then at the end of the day, when it gets to the consumer, it could be completely eaten, or we have wastage in different form, and this waste could be treated or even recycled. But all these also contribute to the environmental impact. And in each of these stages, we also have transportation, which is very big. I think that I'm omitting the T at the top here, but the T for each of these stages. So from farm to production, there's a T to storage, there's a T, and so on and so forth. So this T is transportation, which consume a lot of energy, right? And all these contribute to environmental impact, basically. So the idea is that life cycle assessment would then help us understand and measure all these impact in a fair manner. Now, why does this matter? I'm sure maybe you're asking yourself, why does this matter? Like, why do you have to compare things? Why do you have to compare systems or products or processes? So for me, at the core of this is about comparing two alternatives. So for example, you could choose between an apple or rather an orange, right? And understand which one has a lower environmental footprint. It also helps us to identify opportunities for improvement, like reducing water use on the farm, using more efficient packaging, or even minimizing food waste, right? So basically, essentially, LCA helps us to answer key practical questions such as which product is better for the environment, what farming or processing method leads to the lowest impact, or where is the life cycle where in the life cycle has the largest hotspot, right? Is it at the farm? Is it during transportation? Is it during storage? Is it during processing? Or is it at the consumer? So these are questions that we could answer using the life cycle assessment method. Okay. Then I go to the next slide, which is focusing now on the steps that we have to follow when applying this method, because life cycle assessment is governed by international standards, especially the ISO 14040 and then ISO 14044, which ensures that LCA are carried out in a consistent and transparent manner. Okay, just to highlight that this LCA approach is divided into four main steps. The first step is the goal and scope definition. What does this mean? So the idea is for you to carry out this study or this approach, you have to first define your goal and then the scope of your investigation. So the idea is to ask yourself, why are you carrying out the study? To whom is this study for? So for example, comparing the environmental impact of locally grown apples versus imported apples, or even imported oranges, as the case may be. So this is very important to clearly understand and then to define at the beginning of your life cycle assessment method approach. And then you have the step two, which involves the inventory analysis. Now, what does this mean? So this is where you collect all the data on everything that goes in and out of the system, right? So such as the water use, the fertilizer application, the energy that you would need, for instance, to run the tractor, the packaging material, and also the transportation from one point in the supply chain to the other. So all these data that is involved in the entire life cycle of the product is being collected at this stage, and this you have to define clearly, right? And then the third step is the impact assessment. Now, what does this mean? So this is basically turning those data into measurable environmental impacts like carbon footprint, resource use, water use, or even pollution. And then the last step is then to interpret these results, right? Because again, it's not about having figures and having values, but you need to understand what this means. So you analyze the result to see, for instance, where the biggest impact occur and what can be improved. So these steps make the LCF process very structured, rigorous, and comparable, right? So helping systems, products, and processes develop are better, and also to give policymakers a better way to make decisions. Okay, now let's look at each of these steps. Let's break it down a little bit. So step one, which is the goal and scope definition, is all about setting the direction of the LCA. So we start by asking three key questions. Why are we doing this study? What do we want to assess, and who is it for? So if you could clearly answer these questions, then you already have a very good start for your LCA implementation. And then the next is the goal and the scope, where you have to define what's included in the study and which impact you want to measure. So do you want to consider the entire supply chain? So meaning from farm until it gets to the consumer, or do you want to only focus on the farm? Do you want to focus on the storage? Do you want to focus on the retail? So you have to define basically the boundary, the scope of your study, right? And then we have the functional units, which basically defines or gives us a fair basis for comparison. So, for example, you could say, okay, you want to identify, or you want to investigate or quantify rather, the environmental impact of consuming 1 kilogram of apple, right? Or you could say, okay, the environmental impact of storing 1 kilogram of orange, or serving, 1 kilogram of salad. So you have to define the functional unit very clearly, because that would guide you as to, the data you want to collect, and also the characterization factor, which we're going to talk about later. Okay. Then next, we choose the environmental impact assessment method. So this is also very critical, because the method you choose would define the final value that you get at the end. And again, one thing that we've seen is that each method could give you different final value. But the most important thing is for you to be transparent about it. So meaning you have to define what environmental impact assessment method you want to use. So this is very also important to mention. And then finally, you have to define the limits. So what's excluded? What are the authenticity? Like for instance, excluding minor packaging components, or if you have data gap. So these are the things you also mentioned, right? But just to say that by defining this clearly, your LCA approach becomes more transparent, consistent, and then comparable. Okay, now let's look at still on the first step, which is the goal and scope definition. Let's look at a key concept, which is the functional unit. Okay, because as I said earlier, this is very important for you to define clearly. So functional unit and reference flow together, they define how fairly we compare product, systems, or processes in an LCA. Functional unit describes the core function the product provides. In other words, what it does, and also how it does it. In this case, the functional unit for fruits is the delivery of 1 kilogram of apples ready for consumption within a storage duration of 7 days before they are eaten, just like what just the example that I project on the screen. And then we have the reference flow, which represent how much products and packaging are needed to deliver that function, right? So for the apples, the reference flow could include 1 kilogram of apples packed in a corrugated crate and transported to retail, right? So as you can see on your screen, so we have the functional unit as delivery of 1 kilogram of apples ready for consumption, and then the reference flow is then 1 kilogram of the corrugated crate, or a crate that could carry up to 1 kilogram of apples. So that could then be your reference flow. Just to make it more clearer, let me give you another example for comparison. Let's say, for instance, your functional unit is to deliver 1 liter of orange juice, right? And to do this, you could use 75 cl of orange bottle, and then you could also use 33 cl of juice can. So these two now makes up the 1 liter of orange juice, right? Now in this case, your reference flow could be using, let's say for instance, one and a half of this kind of bottle, or you could use several of the can bottle to make up the 1 liter, right? I don't know if this makes sense. Anyway, so this is your reference flow, just to be very clear on that. So the idea is that by defining both the functional unit and reference flow clearly, we make sure that any comparison, like comparing between fresh produce and processed juice, is fair, transparent, and also consistent. Great. Now that we've defined our functional unit, the next step is to set the system boundaries, right? This, as I said earlier, this tells us what to include and what to exclude in your LCA study. So it's basically it marks the line between technical systems, which is everything involved in producing, transporting, and using, the fruits as an example, and then the environment, which provides input like water, energy, and raw materials. So these are the things that we have to define clearly. So, for example, in a fruit LCA, we might, look at different boundaries. For instance, so you could see here we have like from cradle to gate, meaning from growing and harvesting apples up to the point they leave the packaging facility, right? Or we could say from cradle to utilization or to use, which is extending this to go beyond packaging to the consumer, to when the consumer buys and eat the fruit. I could say, okay, cradle to grave, which is including all the stages up to disposal of packaging and organic waste, right? So this is very important to define first and foremost. And then we could also define the geography. So where do you want to conduct this study? Is it in Nigeria? Is it in India? Is it in Philippines? Is it all the world? So these are things you have to define also. And then we also have the time horizon or the lifespan, which, for instance, as an example of the fruit LCA, we could say, do you want to look at it over one harvest season, or in a year, or do you want to look at it over a couple of seasons, right? So these are things you have to clearly define in order to have a more transparent and consistent life cycle assessment. Okay. Good. And now we go to the second step, which is the inventory analysis, right? I think I touched a bit about this, which is collecting data that is then used to define the impact that your process, your system, or your product would have to the environment. So this is usually very data intensive. Here we collect the inputs such as the energy used on the farm, fertilizer, water, and packaging materials, and then we also have the outputs such as the emission to air from transportation, or the nutrients from runoff water, in the soil, or the organic waste to the soil. So in short, this phase is basically tracking everything that goes in and that comes out of producing and consuming fruit. Okay, and then another very important concept when you talk about the life cycle inventory analysis is the data sources. Where do you get your data? And this has always been the biggest problem or the biggest challenge when it comes to implementing life cycle assessment. But these are some of the ways you could collect your data. You could get your data from EquiInvent, which we are going to talk about later, or GABI, company sustainability report, or even through field or lab measurement. You could also get data from technical people, like people that are in the field and they understand what goes on. You can also collect your data from OEM, so that's operation equipment manufacturing website, where you can get, for instance, the specification of a product or of a system on their website. So these are ways you can collect data, but it's very important to know that for me, this part is probably one of the most important part in the LCA calculation process. Because if you don't get it right, if you don't get the data that you require, then your result may not be reliable, right? So this is very important to mention. And then we go to the step 3, which is then to once you've gathered all the inventory data, the next step is then to translate them into environmental impact, right? But I just wanted to clarify something which some people in the field often make mistakes about. Uh, it's important that you don't just quantify the emission, but rather the impact. And I will explain why. Now, if you look at the image on your screen, right? If you drop, for instance, 1 kilogram of cotton or 1 kilogram of iron, they do not have the same impact, right? Because if you drop it on one's head, the impact will definitely be different. And the reason is because in as much as they have the same mass, the same quantity. For instance, iron is denser compared to cotton, right? It has a higher impact force compared to cotton, and so on and so forth, right? So that's why it's very important that the idea is to focus on the life cycle impact assessment, and not just the life cycle emission. So this is, I just wanted to clarify this. Anyways, now let's look at some definitions about the life cycle impact assessment. Now in this slide, you could see different impact categories. We have a concept called characterization factor, and then you have the emitted substances or resources used. Now, what does all this mean? Now, if once we take the inventory data and we translate it into environmental impact using characterization factor, we have to match, we have to make sure that this is done in a consistent manner. So the characterization factor tells us how much each emission or resources contributes to a specific type of impact, right? So for example, the CO2 affects climate change, while pesticide contribute to ecotoxicity. Why, you have lithium extraction, then is linked to resource depletion, and water use, it relates to water scarcity. So each of these categories represent a different environmental issue, from long-term climate shifts, as the case for as it is the case for climate change, to local water shortages when you talk about water scarcity. So in essence, this phase helps turn raw data into meaningful environmental insights that show where the biggest pressure on the planet come from. Okay. And here you can see how the impact assessment connects emissions and resource use to their broader environmental consequences. So this is basically what we call the cause effect chain, when you talk about life cycle assessment. So here we typically assess impact at the midpoint level. What does this mean? So things like the global warming potential, acidification, ecotoxicity, and so on and so forth. And why? Because these are more measurable and are less uncertain. But when you look at further along the chain, then you have to think about the endpoint level, right? Such as the impact on human health, ecosystem quality, and resource availability. So basically, these give a more intuitive picture, but come with more uncertainty, right? So that's why it's good that we have these categories. So you have the midpoint categories and then the endpoint category. So midpoint results are great, in my view, for scientific precision, while endpoint results are useful for maybe communicating the bigger picture to a more broader audience. Okay. Now let's look at some of the options when you talk about midpoint method or endpoint method. So there are not just only one way to carry out an impact assessment. There are many LCIA, which is the life cycle impact assessment methods, which have been developed by different countries or different regions. So on the left here, we see the midpoint method like RECIPE, CML, IPCC, GWP, and so on and so forth. So all these focus on individual impact categories, such as the climate change or acidification, right? And then on the right, you have the endpoint methods, which go further to express, excuse me, to express results in broader terms, like human health, ecosystem quality, or resource availability. So in practice, what is commonly used is the IPCC or RECIP, which are two main methods because they connect both midpoint and endpoint indicators, giving practitioners the flexibility, to play around with the method depending on the level of details that is required. I just want you to know that the method you choose can influence how the impact is represented. So I think I mentioned this earlier, but I also wanted to emphasize this again. Now let's do a simple exercise. How does this come together before we then go, deeply into what we've done in your virtual coaching assistant project? Now, on your screen, you see a simple calculation on how we can actually calculate the environmental impact of in the life cycle assessment phase. Here, you have the elementary flow, which is the carbon dioxide, or in this other example is the hydrocarbon chlorinated. Then we apply the characterization factor that expresses how much each of the substance contributes to the specific impact category, right? So yeah, for instance, we have 2 kilograms of CO2 with a characterization factor of 1 gives us 2 kilogram of CO2 equivalent, right? And then if you look at 2 kilogram of hydrocarbon, and the characterization factor is 13.8, it gives us much more higher, which is 27.6 kilogram CO2 equivalent. Now, what does this mean? So you can see that this means that the elementary flow is very important. So even though you have the same quantity of, after your life cycle inventory, you have the same amount of emission. You have 2 kilogram here, you have 2 kilogram here, but the characterization factor differs between the two type of impact category. You get a different result, right? So this is very important to see, and this is exactly the concept that we implemented, in our solution. And then the last step, which is the interpretation of your results. So this is also a very important step because it's not about running a calculation, but if you don't know what to do with the results or with the final value, then this could become a problem for you or for your intended users, right? So all the results from the impact assessment needs to make sense. So we ask key questions like, where do the main environmental impact comes from? Where are the biggest opportunities to improve? What uncertainties could affect our conclusion, and so on and so forth. So, for example, in the fruit LCA, we might find that most impact come from irrigation or cold storage, and less, let's say, from the consumer, as the case may be. So these are the things that we need to remember when interpreting the result. So this step, as I said, help us to ensure that our conclusions are accurate, transparent, and meaningful before taking any decision. Okay, great. Now, how did we deploy these for your virtual coaching assistant project? Let's look at what we did. Now, I am presenting this based on the steps that you've seen. So from step 1 to step 4. So step 1, what we did was we first defined our goal specifically, so very clearly. And our goal was to assess the greenhouse gas emission from storing fruit in solar-powered cold rooms compared to natural shed, right? And then our functional unit was, or we used rather, 1 kilogram of fresh produce stored per day. So the idea is for us to get a consistent basis for a comparison. Then the next thing was our scope. What's the scope? So the scope for us is focused on only the storage phase. We excluded cultivation, transportation, consumption, and so on and so forth, because the idea is to to make sure that they remain equal across all scenarios, because we're looking at different countries. We targeted Nigeria, Philippines, and India for this solution. So in order to avoid the data bias and how data could affect the results, we focus more only on the storage phase. And the key drivers, sorry, we considered were energy use, refrigerant, food loss, and waste, with the system boundary defined as around only the cold storage unit. Okay, just to mention that for this we assess different um, solar powered configuration. So we assess solar power cold rooms with batteries. We assess solar power cold room with ice block. We also assess solar power cold room with different phase change materials like like the like wax, for instance, right? So these are the basically 4 different configuration that we included in the Cultivate app. Okay, and then the next step is the life cycle inventory analysis, where we model the input flow and also the output flow. So our input flow include the likes of electricity for cooling, uh, maintaining the storage temperature, respiration loads, battery charging, and refrigerant leakage. Each parameters play a key and distinct role in defining the emissions, right? So for instance, now, electricity for initial cooling, we have electricity to maintain the cold room temperature, we have electricity to offset respiration heat load. We also had electricity for thermal storage, electricity for charging batteries, and then we also have the refrigerant leakage. So which all these contribute heavily to the environmental impact of using a cold room, right? Now, just to mention that there are more parameters we should have considered, but we didn't consider, for instance, the infiltration or transmission load. So these are things that could also happen, when running a solar power cold room, but we didn't mention this, or we didn't consider this. And then our output flow include cooled food, fruits and vegetables, food loss and waste, refrigerant leakage, and also emission to air. So here we track food loss with cooling, and then versus food loss without cooling, right? Based on our baseline survey that we carried out in these countries. Great. Now, to carry out our life cycle inventory, we use both the literature data and real-time field data collected through the cultivator. As I said, the app gives us a granular input like temperature, energy use, produce mass, and refrigerant type. So these for us are important parameters that we collected using the Cultivate app. Okay, just a little bit, just to show some of the equations that we used for this calculation. You don't need to think too much about this, but anyways, these equations allowed us to break down the electricity and material usage in the cold room, whereby each step from initial cooling to storage maintenance, battery charging, and even food loss is accounted for. And then the output like refrigerant leakage or food waste are also then used to calculate emissions, right? So I also wanted to mention that we kind of link these the temperature that is being collected in real time from the app with this equation. So we're going to see in the subsequent slide how this temperature reading are collected. Okay, and then the next thing is the step 3, which is the life cycle impact assessment. As I already explained, the different categories. So here we use midpoint, as is often the case. The idea is we translate all these inventory flow into climate impact, right? Using, in our case, the global warming potential, or what is often called the GWP, which is expressed in kilogram of CO2 equivalent per the functional unit. So we use the environmental footprint 3.0 method from the European Commission's Joint Research Center with data and characterization factor from the EcoInvent version 3.8, which we collected through CIMA Pro version 9.5. So, I mean, you don't need to care so much about all these details, but it's good that I mentioned these. So this is how we, collected data for our characterization factor, which was then used to match the life cycle inventory, right? As I showed earlier. And then each input is then multiplied by its characterization factor. So for instance, at the end of the day, we have the characterization factor for solar electricity at 0.0757 kilograms CO2 per kilowatt hour. And then we have refrigerant as 15.124. We have food loss, we have food waste, and so on and so forth, right? And then finally, once we get the total emission for storage, we can then interpret these into the amount of emissions avoided, or the amount of the amount of emissions avoided, which is just a simple deduction between the difference of the emission from cold room, without cold room, with that from cold room, using cold room. So this gives us a direct comparison between cooling and then no cooling scenarios. So a typical interpretation is shown at the bottom right of your screen, where you see a base case calculation that we did for cold room for cold ops cold room at Ile-Ife, Nigeria, where we see that the environmental the environmental impact of using their cold room was 61% lower than without storage, basically. So this is a typical example of how the calculation was carried out. And then we move next to how then do we implement this in the Cultivate app, right? So this is a system architecture, basically, of the process, how this was implemented. So it starts from power source, yeah. So we have the solar grid, battery, and hybrid systems which supply energy to the cold rooms. Now, these cold rooms store crates of fresh produce, and then each of these crates, is often digitally tracked through the Cultivate app. And then from there, data flows to the Cultivate database, yeah, where we capture all the key contributors to CO2 emissions. So with cooling, this includes electricity used for cooling fruits, charging batteries, producing ice, and so on and so forth, as I already shown earlier. And we also track refrigerant leakage, food loss, and also bio-waste. So for comparison, we separately track emissions from food loss in scenarios also without cooling, right? So that the idea was so that we can have a basis for comparison. That this process, we then implemented this process using Python script, which collects this information daily and then calculate the emission for cold room and also without a cold room. To mention that in order to be very transparent, this calculation also draw on standard CO2 parameters from eco-events, as I said earlier. So we use eco-event to collect our characterization factor for India, Nigeria, and the Philippines, right? And then finally, we show this in what we call the Cultivate Impact Dashboard, whereby different user categories could then see, most especially the cooling service providers, they could then see how much CO2 equivalent, are they saving by using, cold room. And with this, they could also use this to a little bit market to their consumer or to their customers, basically. So this is also very important to mention how this whole concept is able to drive businesses in sub-Saharan Africa and the global south in general. Okay. Now this slide here shows how the Cultivate app streamlines data collection for each code room setup. So you could see we have user information where user can quickly enter all key parameters needed for the lifecycle inventory, from power source, whether it's solar, diesel, or grid, to storage volume, installation details, refrigerant type, and charge. So all this information are then collected. At the back end, of course, then this is then linked to the lifecycle code that that's been developed, and then the calculation is implemented. Now, what is important is that anytime a user update is done or there's a modification, this inputs the system automatically triggers a real-time recalculation. right? So this ensures that the environmental impact assessment always reflects the most up-to-date condition. Our approach, I would say, makes the process both efficient and responsible to help operators, cooling service managers, not just only to track emissions accurately, but also to optimize the performance of their cooling units. Talking still on the data that we collect, you could see that from the slide that Cultivate app goes just beyond data entry, but it can also provide real-time monitoring and actionable insights for each code room. So on the left, you see an example of the temperature history where users can track how room conditions evolve over time alongside the current temperature reading. So now this information is not only valuable for operators, but also feeds directly into our LCA models, where it helps calculate energy consumption, potential food loss, and then, of course, the overall environmental impact. And then on the right, you see the analytic view, where users can instantly measure outcomes like changes in food loss and so on and so forth. In this case, the system is showing the reduction from 80% down to nearly zero. This is just an example, so it's not really an actual case. But basically, by visualizing both the operational and environmental metrics in one place, the app also empower users to assess the condition of store produce, spot and resolve any potential issue quickly, and then to optimize their energy use. So it's good that we emphasize this. And then this slide here shows the LCA, how the LCA results are presented through the Cultivate Impact dashboard, right? I gave a glimpse earlier when I showed the system architecture. But on the left, you see an example where users can track food loss evolution. Here, food loss has been reduced, as I said earlier, from 80% to almost zero. But the dashboard also show more than that, right? It also gives us, other matrices like the individual contributors, like for of the fruits, so or the crates or the fruits. So this is something that is also very important to mention. You can get the overall impact, but you can also get the specific individual contributors to this overall impact. So this is very important to highlight. Great. No, and then I would say maybe finally, by tracking this environmental impact in real time, the idea is for us to identify opportunities to further cut emissions, improve efficiency and revenue, and also to minimize waste across several operations. So basically, this dashboard makes our life and the life of different stakeholders easier, right? So you could see the benefit of storing, and then you could also see what is going wrong in your operation in order to adjust your operation. So this is good to highlight. Great. And then this brings me to the end of my presentation. So just to wrap up, for me, the key takeaway here is that solar powered cold storage can strengthen food security and improve farmer incomes. It can contribute to climate solutions when deployed, of course, reasonably. So our task now is to ensure that this system are scaled with the right data, the right technologies, and the right safeguard in place, so that cooling becomes part of the solution and not the problem. So please, if you have any question, this is the time to ask. Thank you.
Okay. Oh, you're already having or showing the onboarding kit.
Yeah.
Great. So below this window, you have the opportunity to ask questions. There is this small box where you can fill in your questions and, of course, your name if you want to drop it. It's anonymous, so no one else who's in the room will see your question except from Daniel and me. But of course, you're also welcome to just unmute yourself, show your video, and ask the question directly to Daniel. And maybe we can have a small discussion. Daniel, if it's fine for you.
Yeah.
Yeah.
Amazing. Yeah.
Maybe you can jump also to the newsletter slide.
Yeah.
So that we have shown this as well.
Okay.
Yeah, great.
Any question? I could call. I'm seeing familiar faces or familiar names here. I could ask. I could call somebody randomly.
Simran has a question.
Yes, Simran. Okay, go ahead.
Yes, thank you, Daniel. It was a really, really interesting presentation, and my question would be more on if you were to build on the LCA model and refine it, what would be the first things that you would look into? Um,
That's a
yeah,
good question. I would say extend it beyond storage because there are a lot of factors pre-storage that affect the food evolution or the food quality evolution. So I will build it beyond storage and also to see not just only the impact of solar power cold room or using solar power cold room, but also the processes before that, like cultivation, the transportation. How does all this feed into the overall environmental impact reduction? So I think I would focus more on extending the current scope from this from storage to even probably to the point of consumption. I think so. This is the first thing I would do.
thank you, Daniel, and just taking the opportunity and also warming up the stage for other people to ask more questions. Um, I understand that this is a very big endeavor, so I want to ask you what sort of challenges are currently in the way to being able to scale it to the extent, or also even within the current model, what sort of challenges did you face when looking for data and beyond?
Yeah, I mean you've mentioned it already. So I would say the biggest challenge is data. So data is, I know we are collecting data with the Cultivate app, but even at that, is still not sufficient. We need to. So most times, what we do is we have to kind of intimate the users to provide this information. So it's not something that occur naturally. So I would say for me, the biggest problem would be data, and even the data, the parameters that we're collecting are still not enough. So we still depend largely on data from literature, which isn't often very accurate, right? So this is I would say data, and the second thing would then be maybe the methodology, because right now we are using characterization factor from eco-invent, which has not necessarily been updated for a long time. So maybe this is also another thing that we could work on. When I say methodology, I mean the life cycle impact assessment method, so the midpoint method, right, that we are using. So it would be nice to maybe compare between eco-invent and another database. I think this could be something that we could do. Yeah. Uh, any question? Maybe I could. I'm seeing names here that I'm tempted to ask. York, do you have any question for me?
Hi, Daniel.
Hey.
Good to see you. I hope you hear me.
Yeah, I
Well,
can.
I could ask a follow-up question on Simran.
Yeah.
If you could, because I understand that this is an issue, right? Where to
Yes.
get the right database,
Yes.
and what would be your, let's say, on your wish list to have regarding a centralized maybe database to have it, and do you see this coming, or is that something that is being developed maybe from a bigger organization?
Yeah, no, that's a good point. I would say yes and no. So there's a big effort now by several organizations, especially in Europe, to try to make different LCIA database robust, right? So they are developing different databases, or we're not developing different, but building upon the existing ones, like Eco Event, for instance. But the biggest challenge, in my view, is still that these databases are not open access, right? So, for instance, now the Eco Event, we often get them through SIMA Pro, which SIMA Pro is not free. So you have to, you need a license to get this. So for me, I would say this could be a challenge, especially with regards to implementing these, by stakeholders in, LMIC, so the low and middle income countries. So for them to be able to access these kind of databases, so they need to these systems or these databases need to be open access. So for me, that's the first thing I would try to to work on to see how to make this accessible to everyone. So that's the first thing. And then just to add on the second question you asked, if there are efforts being done, I would say yes, there are efforts being done, but most of these efforts are done in isolation. So what I imagine would be a bit of collaboration between different teams, doing this. For instance, just give an example. In Switzerland, we have a group at EMPA that is developing this digital database for all products, right? And then we have another group also called Digital Switzerland that is doing something similar. So they have different people doing different things, and then there is no really communication between these entities. So for me, it would be nice to have like a common ground where everybody pool all their resources together to have something more centralized, and then make it an open access system.
Interesting, yeah. So the data is there, but it's behind the paywall, basically.
It is. Yeah.
Thanks.
Okay. We have 3 more minutes, I think.
Yes, but there was a question incoming.
Oh, okay.
Yeah, you can see it
Let me check
in the back end.
quickly. Okay. Yeah. Oh, there are questions. Okay, let me quickly check. Okay. I can't see. I mean, there's a lot of.
Should I read
Okay.
it out?
Yeah, please. Yeah, that'd
Yeah.
be nice. Yeah.
Okay.
Nice.
The question is, are there competing method? I'm sorry, I'm just not into the topic
Methodology.
Yeah, for LCA in the agri-cooling sector, and what is the point of these? Second, does they support certification?
Could you read the first part? Sorry, again. The first part. Could you read it again?
Yeah,
The first part.
with the difficult word. Okay, are there competing
Maybe I can
methodologies?
step in,
Yeah.
Jackie. Thank you so much. The question, Daniel, is: are there any other competing methodologies for LCA or for calculating GHG emissions in the agri-cooling sector? And in the end, what do these do? Do they help get some sort of carbon certifications? Is there a core reasoning
Yeah, no,
behind
that's
it?
a good question. I would say, to my best knowledge, I would say yes. There are a few other methods that are being used to calculate greenhouse gas emission, but these methods do not necessarily follow the LCA approach, right? So LCA is already standardized, so it follows the 4 steps. So are there different kind of LCA? The answer is no, because it's still the same method. So step 1 to step 4. But are there different methods used to calculate GHG emission or CO2 emission or whatever it is? The answer is yes. But these methods are mostly, driven by mathematical formulas, right? And how you present the results. Do they give certifications? I would say no, because well, there are entities that deploy some of this method and still give certificates, but they're not mutually exclusive. So meaning they're not together, right? So you could still see bodies that give certificates for carbon worthiness and so on and so forth, without necessarily deploying or having any of these GHG calculation approach, right? So these are 2 different things, I would say. Any other question from the chat? Okay, I would say I can't see any question. Yeah.
No, there are none.
Okay, perfect. So any last chance from anybody to jump in and ask a question before we close the session? Anybody else? Okay, great. Thank you guys for joining my talk. It was really nice, to have this great interactive session. And please don't forget to join the next sessions. I don't know, Simran, when is the next one? You want to mention maybe just for people to be aware?
Yes, so everybody, you can move back to the main event page. So the link that you were using before you joined the site session, And we have a lunch break for an hour to those that are in the same time zone, and we will be resuming at 1:30.
Perfect.